This video will help you through the review for Unit 16 over data analysis. So the first one says the rule for finding the nth term in the sequence is x times x minus 2 divided by 4. What is the fifth term in this sequence? So fifth term is going to be an x or an n value of 5. So all I'm going to do is plug in a 5 where I see x's and simplify this number. You can do it a couple different ways. I'm just going to do it the most basic way that looks the same as what's on my paper. You could also plug this into y equals and go to the table to see where x equals 5, what is your y. So 15 over 4 is going to be my y value. Question 2, the expression below describes a pattern of numbers. Identify the first 5 terms in this sequence. So I'm going to go ahead and put this into y equals. And then I'm going to go ahead and go to my table. And remember, they are wanting the first 5 terms for this sequence. So the first 5 terms are going to be 7.5 because that's the first term. Okay, sorry. So the first term, our one term, is 7.5. Our second term is 8.2. Third term, 8.9, 9.6, and 10.3. So remember, with these, the first 5 terms, you start at 1 because we can see what the original term was that was already given to us. Number 3, we have a table describing the arithmetic sequence where x represents a number's position. What is the missing value? So they're telling me what that function is going to be here, 3 times x minus 2. And they're giving me an x value and they want the y value. So this is another quick plug in. We're going to take 3 and then plug in 9 minus 2. And so that value would be 21 based on that formula. For number 4, we have an expression 2/5 m plus 3 describes a pattern of numbers forming an arithmetic sequence where m is the number's position in the sequence. Identify the first 5 terms. This is similar to number 2. I'm going to put this into y equals. I'm going to go to y equals and type in 2/5. Instead of m, I'm going to use x plus 3. And then I'm going to go to the table. The first term is 17 over 5, so I'm writing the y values for 1 through 5. So these are the first 5 terms of the sequence. Remember, it's the first term, the second term, third term, fourth term, and fifth term. For number 5, we have a pattern of smiley faces. More smileys are added with each step. Write an expression that could be used to determine the smileys in the nth step. So from step 1 to step 2, I add 2 smileys. From 2 to 3, I add 2 smileys. And then 3 to 4, add 2. So because I'm adding the same amount every time, this is linear. So I have steps 1, 2, 3, and 4. And then I have 2, 4, 6, and 8 smileys. So because it's linear, I'm going to do stat calc 4. And my expression will be 2 to the n plus 0, or 2 to the n. You could also put 2 to the x. It's the same thing. Number 6 says a study of fluke cases are growing exponentially. That's going to be a keyword for me. As seen in the table below, write a regression to represent this data. So because I have a table, I'm going to go to stat calc, and I'm going to enter my x's in L1 and my y's in L2. Feel free to pause the video if you need to. Now, because it says exponentially, I'm going to do stat calc and option 0. So stat calc. You can hit the number 0 or scroll down to 0, the exponential regression. And so my a value is 4, and then b is 3 raised to the x. So 4 times 3 to the x. Keep in mind, this would be incorrect. The x is not down with the 3. The x is an exponent. That's what that little caret on your calculator means. So make sure you don't write it as a regular n. Make sure you write it as an exponent. Number 7, the nth term of a series is determined by the expression shown there. What is the value of the 99th term in the series? So we're going to plug in 99 for x and simplify. So again, I can do this 2 different ways. I can just straight up type in or plug in the number 99, just like I'm about to. I can also put this in y1 and scroll all the way to 99. That's going to take you a hot minute. So I'm going to go ahead and plug this in. 2 times 99 squared minus 3 times 99. So everywhere I see an x in the expression, I'm putting 99. And I get 3,861. Number 8, 8 friends were recorded the following data about their height in inches and their weight in pounds. Write the line of best fit for the table if it represents a quadratic function. So quadratic is going to be StatCalc 5. So I'm going to enter this table into StatEdit and do StatCalc 5. So this is going to take a second. If you need to pause the video, you can. And then StatCalc quadratic function is option 5. So the line of best fit, this is kind of an ugly one. So I'm just going to round at decimals. So 0.06x squared minus 1.94x plus 26.58. Keep in mind, if it says quadratic, that means I need an x squared or an n squared or a letter squared. So if I don't see a squared, if this is multiple choice, I would immediately mark out anything that does not fit the pattern for a quadratic function. Number 9, scatter plot below shows the age and maximum vertical leap for 6 girls. Based on the graph, write an equation to represent the line of best fit. So I can see from here, this one is about a line. That was not a good line, but line of best fit. So this is going to be linear. So I'm going to go ahead and fill in my table. This point right here has an x value of 5 and a y value of 5. This point right here has an x value of 8 and a y value of 10. This point has a 12, 15. This point is 12 and then like 16.5. That point is 14, 16, and it's okay if these aren't exact. 16 and 16.5. So I'm going to go back to StatEdit. Remember, if you ever want to get rid of everything in the list, you click clear. You never ever click delete when you have those lists highlighted. So I'm typing in my numbers. And I'm going to go StatCalc 4 because I can see from the dots it's pretty linear. And then if you see the word line of best fit, but it doesn't tell you what type of function, you assume linear. So y equals 1.10x plus 0.89. Number 10, Andre is a quarterback from his high school football team. During a game, he throws a pass directly down the field to another player. Height and distance of the football as it was thrown, as it travels through the air, is recorded at regular intervals and shown below. Using technology, find the quadratic equation that fits the information provided. So I have a table. I'm going to come back in here, use my StatEdit, pretty much like we've been doing all unit. And then this one tells me that it's quadratic. I can also see that because the amounts that are increasing and decreasing are changing. It's not being added or subtracted by the same thing, and it's not being multiplied. So stat calc option 5. And that is going to be my equation. That negative 0.0625 you could turn into a fraction. So you might also see it as negative 1 over 16x squared plus 2x. Number 11, the following is a geometric sequence. Remember, geometric means it's exponential. It means we're multiplying by something. We can also tell because our numbers are getting gigantic really quickly. So write an equation below to represent the function for this sequence. So I have 1, 2, 3, 4, 5 terms. My terms are negative 14, 98, negative 686, 4802, and negative 33, 614. So I can see these are getting really high really quickly, okay? So I'm going to click Stat Calc, and because it's being multiplied or because it's geometric, I don't care which way you remember it as long as you remember one of them, it's going to be exponential. Oop, and I made the silly mistake. You can't put negatives in. We're going to have to fix that part in a second. Sorry, that was my bad. So stat calc 0. And so my function, all I really get from this is that 7, remember? So 14 is my number in front. The b value is what I get from the table. I'm sorry, from the calculator. And because it's negative, I use negatives. And then x minus 1. Okay? You might have also been taught to type in your terms with zeros, which will give you a better starting here. And then you just have to change the negative. So we started at negative 14, and then because we have negatives, we have a rate of negative 7. Number 12, we have a sequence of numbers that are shown below based on this information. How can we find a to the n? So I'm going to do my table with little and big numbers. So my little number of 2, big number of 2. Little number of 3, big number is 5. Little number of 5 has a big number of 11. Little of 6 has a big of 14. And little of 7 has a big number of 17. So with these, I can see my x's are not increasing by the same amount, but remember when we have little ones like this, that's going to be linear. You can also use these down here because they're increasing by the same amount. The x's are increasing by the same amount. So my y's, I can check, are also increasing by the same amount. So for number 12, I'm going to go stat calc 4. It is linear, so I could use 3n minus 4 or 3x minus 4 either way. Remember, x's and n's are interchangeable. Number 13, distance traveled was recorded at different time intervals as shown below. Using technology, find the quadratic equation that fits the table. So I'm going to plug this in and run a quadratic regression. So from here, I'm going to go stat calc option 5. And my quadratic regression, my a value is 7.1, and I don't have b or c, so it's just 7.1x squared. A geometric sequence can be used or shown using this 5a to the n minus 1. Remember, the n minus 1 is what tells us that it's geometric because we're multiplying also. Where a to the 1 is 7 and n is a whole number greater than 1. What are the first 4 terms? So first thing I'm going to do is write my function. So my first term is 7. My rate that is being increased is 5. And then that will be to the x minus 1 because it's geometric. So I have 7 times 5 raised to the x minus 1. From here, I can go to the table. My first term is 7, like it says. And they want the first 4 terms. So 7, then 35, then 75, then 875. The other thing you could do if you can't remember how to write your equation is we start at 7, we multiply it by 5 for the next term, times 5 for the next term, and times 5 for the next term. 15, we have a rule for finding the nth term for a certain sequence shown. Find the 7th term of the sequence, so we're going to plug in 7 for x. So I have 2 times 7 out front, and then in parentheses, 3 times 7 plus 4, and then a 6 on the bottom, and we get 175 divided by 3. Sixteen asks us to draw a picture of a quadratic function with a range, so y values, greater than or equal to negative 6. So my y's are greater than or equal to negative 6. You can draw whatever you want as long as your y's start at 6 and go up from there. You can make it a quadratic, you can make it a squiggly, you can draw whatever you want, but something that does not go below negative 6 on the y's. Number 17, students in Lily's class were trying to find the perimeter of these two figures. They used a table, or they created a table. What is the perimeter of the next figure? So I can plug this into stat edit. I can also just see if I can find a pattern. So 4, we would add 2 to get to 6. 6, I would add 2 to get to 8. And then 8, I would add 2 to get to 10. So if I add 2, I would get a perimeter of 12. Now again, if you wanted to plug this into stat edit, you're more than welcome to. You do 1 through 4, stat edit, it's linear. You'd get your equation and then you'd plug in a 5. Number 18, identify the next term for the geometric sequence below. Geometric means that it's going to be exponential, so I'm looking for something to be multiplied. So if I take the second number and divide it by the first, I get a value of 2. So that means they did this times 2. If I take the third and divide it by the one in front of it, I get 2. And I can keep checking these. All of these have a value of 2. So that means all the way down, they're multiplying by 2. So the next term is going to be 182.4 times 2, which would get me to 364.8. Number 19 is another review. Write a linear transformation for the linear parent function f of x, where g of x, so g of x is going to be my new one, is reflected across the x-axis, so that means a negative in front, vertically stretched or steeper, that just means a number bigger than 1, so it doesn't matter what number I pick, and shifted to the right, which means we're going to have an x minus any number you want in parentheses. So this is a x minus a number, this is a bigger number than 1, and reflected across x is a negative. So your answer for 19 could look way different than mine, just has to have those things. And then number 20, find the slope for the function. So in order to find the slope, I need y by itself. So I move x to the other side. And then divide everything by negative 6. So I get 1/3 x minus 4/3. And then they specifically asked about the slope. So that is the number in front of x. But you cannot identify the slope until you have solved for y completely.